Pierre Louis Maupertuis was born on 17 July 1690 in Saint-Malo, France, into a wealthy Martin family. He received a classical education in mathematics and sciences. First, at the Jesuit College, and later at the prestigious Collège de la Marseille in Paris. His early interest in mathematics and natural philosophy laid the foundation for his influential contributions to science. Maupertuis became renowned for his work in mathematics and physics. He became renowned for his work in mathematics and physics, particularly in his application of geometry and calculus to natural phenomena. Early in his career, he worked closely with members of the French Academy of Sciences. He worked closely with members of the French Academy of Sciences early in his career, where he gained recognition for his work. He gained recognition for his work on celestial methods and optics. One of his key contributions was the principle of least action. One of his key contributions was the principle of least action, which proposed that nature operates in the most efficient way possible. This principle influenced later developments in physics, including the work of Euler and Lagrange, and remains a cornerstone. Remains as a constant of variational calculus and classical mechanics. This principle remains a cornerstone of variational calculus and classical mechanics. Maupertuis is perhaps best known for his involvement, in the scientific debate. Maupertuis is perhaps best known for his involvement in the scientific debate about the shape of the Earth. In the early 18th century, the question of whether the Earth was oblate, that is flattened at the poles, or rounded, that is elongated at the poles, was a significant scientific controversy. So Maupertuis dived into the debate in order to find the absolute answer. Maupertuis led an expedition to Latin. A modern-day Finland, to measure the length of a degree of meridian near the Arctic Circle. The results of his measurements supported Isaac Newton's hypothesis that the Earth is an oblate sphere. This work earned Maupertuis widespread acclaim and solidified his reputation as a leading scientist of his time. That work of expedition, Latin, were to measure the length of a degree of meridian near the Arctic Circle, and in widespread acclaim. The result of his measurement supported Isaac Newton's hypothesis. The Earth is an oblate sphere. That is an oblate theory. This work earned Maupertuis widespread acclaim and solidified his reputation as a leading scientist of his time into biology. He went into biology, where he made some of the earliest contributions to evolutionary thought. In his essay on cosmology of 1750, he speculated on the role of random variation and natural selection in shaping the diversity of life. He proposed that small changes in organisms could accumulate over time, a concept that prefigured Darwin's theory of evolution by natural selection. The top three principle of this action was not only a scientific proposition, but also a philosophical one. He saw it as evidence of a harmonious and purposeful universe, governed by reason and divine design. This philosophical interpretation, this philosophical interpretation influenced enlightenment thinkers and placed Maupertuis at the intersection of science and metaphysics. This philosophy, this philosophical interpretation influenced enlightenment thinkers and placed Maupertuis at the intersection of science and metaphysics. In the year 1740, Maupertuis moved to Bali, where he was invited by Frederick the Great of Prussia. He was invited by the Frederick of Prussia. He was invited by Frederick the Great of Prussia to lead the Berlin Academy of Sciences in 1740. As its president, he worked to modernize the academy and promote interdisciplinary research. However, his tenure was marked by controversies, including a public forum with philosopher who ridiculed Maupertuis in his writings. Despite these challenges, Maupertuis continued his publication. Maupertuis continued to publish influential works and maintain his prominence in European intellectual circles. Maupertuis died on 27 July 1759 in Basel, Switzerland. He died in prison after a prolonged illness. His contributions to science, philosophy, and mathematics have had a lasting impact. He is remembered as one of the key figures of the Enlightenment, whose work bridged the gap between empirical science and philosophical inquiry. Here to this entry, we cannot forget about the principle of least action, foundational in physics and calculus, influencing modern mechanics and various methods. You can also recall about the Odyssey. His Lapland expedition provided critical evidence for the art of nature. Concerning evolutionary ideas, his early thoughts on heredity and adaptation that anticipated later evolutionary theories. His interdisciplinary influence raised science and philosophy, contributing to Enlightenment thought. Maupertuis has a lot of publication. Some of his selected works are as follows: like the dissertation on the different shape of stars of 1732, his book Essay on Cosmology, Essay to Cosmology of 1750. And another selected work of Maupertuis is The Art Figure Determined of 1740. Pierre Louis Maupertuis remains a significant figure
in the history of science, celebrated for his pioneering work across diverse periods and his philosophical reflections on the natural world. If you want to know more about the life and work of Pierre Louis Maupertuis, you can refer to the following book references. You can refer to his book Venus Physique, which was in French, later translated to English version. The title The Physical Venus. You can also refer to the book Dissertation on the Different Shapes of Stars. You can also refer to the book The Law of Resting Bodies. You can also refer to the book with the title Letters. You can also refer to the book with the title Philosophical Reflections on the Origin of Languages and the Meaning of Words.